So we are going to run this lab, and I want to talk a little bit about the procedures in the background, and then we'll get into it and uh, talk about how we're going to analyze that data as well. So as you look at the lab sheet today, you see the purpose there is to observe properties of ionic, covalent, and metallic substances. Specifically, the properties we're going to look at is what happens when they're subjected to some heat energy. Okay. We know a little bit about when we heat things up, sometimes they will change phases of matter. They might melt or they might boil and so forth. Well, a lot of that has to do with something we discussed a little bit today, and that was those intermolecular forces that are kind of holding not the individual molecules together, but holding the molecules together with their neighboring molecules, if you want to think of it that way. All right. And so we're going to look at some different substances and try to see what effect heat has on them, and then maybe tie that in a little bit to the type of chemical bond that's holding that material together. So we're going to use a little salt, we're going to use a little sugar, and we're going to use some lead. Okay. All three of these things are things that shouldn't be totally unfamiliar to you, obviously, especially the first two. But you probably don't have a ton of experience with lead because, well, lead is a poisonous substance. So we want to be sure we're not handling it too much and handling it with care. But a lot of you, use lead, and you have it in sinkers, maybe when you're fishing or so forth. There's a lot of different uses that lead gets put to. Fortunately, we've taken it out of most of our paints these days. But so there you see the data table that we're going to fill out, and I'm going to set up 3 test tubes and 3 Bunsen burners. If you were doing this in the lab by yourselves, I probably would have you do it one at a time. But because you're in the safety of your own homes, we're going to do all 3 at the same time. Okay, we're going to run them all simultaneously. That'll speed things along, and we can fill out the whole data table in one fell swoop. You see the data table is just asking for observations of each of those 3 substances after cooking for 1 minute, after 2 minutes, and so forth, all the way up through 4 minutes. And I'm not looking for a ton of information or detail. We just kind of want to see, well, what happens? What happens to them? Tell us what you see taking place. For some of them, you might see very little happen at all. Some you might see a little bit happen. Some you might see a lot of change take place. All right. And so that's what we're going to try to record. We always want to, in science, when we do a lab, we want to keep track of our observations along the way to make sure we are notating that. Once we've done that, we will, we got some analysis and conclusion questions that we'll address, but in the meantime, we just want to fill out our data table. And so I'm going to set this up for you as we look at our lab arrangement or apparatus. I have 3 test tubes and ring stands set up, 3 Bunsen burners. And what we're going to do is, like I said, we're going to try to run all 3 of them simultaneously and see if we can't get a good result from there. I'm going to heat everything up today in test tubes. Okay, we're just going to use test tubes here. I'll start out here. I've put my salt in. Just pour it in from the container a little bit, put a little bit more, and then whoa, that's plenty. Now, a test tube clamp simply slides on in here, and with this little wing nut, I can tighten it up into place and lock it down into where I want it to be. Next, I've got my sugar. I'm going to use a little tool we call a scupula to get the sugar out. Scupula is just it's like a metal spoon, but designed with a little different shape. It actually is going to allow me to pour the sugar directly into the test tube a little bit easier. Sometimes spoons, we do too much spilling. One more bit in there. Who doesn't like a lot of sugar? All right, so we try to keep it close to the same amount as salt. And once again, I will clamp it into place with my Bunsen burner. Last but not least then, I'm going to get my lead. The lead is in this red dish back here. Lead, if you're not familiar with what it looks like, is kind of a bluish gray. We've got little balls of it here in the dish. And I'm just going to pour some into the bottom of this test tube here. And we'll clamp that into place. We'll try to keep all of them about the same height over the Bunsen burners flames. Now the Bunsen burner flames, I want to keep those pretty consistent too, so we can see if there's a big difference in how some react. You know, we're not heating one up a lot differently than the other ones. And so I'll light up my Bunsen burners. Turn on my safety goggles. So I got my Bunsen burners going. Again, they all have a pretty similar size flame in order that we can keep a fairly consistent test. And what I want to do is I'm going to need to time this. I'm going to set a little timer. And so that for every minute that they are running, we can make our observations and record them on our data table. So I'm going to slide my Bunsen burners underneath each of these. And we'll start cooking them and see what kind of results we get. Now it looks like we're not lined up really well there with the sugar. So I'm going to turn this a little bit. Cord is getting pushed around, but all right, so we'll start our timer and away we go. We're just looking to see, again, what changes happen due to the heat that's being put on them. Let's try to zoom in a little bit closer. It's going to be a little tough to see for some of you for what's occurring, but not much happening in the salt container. The sugar obviously has got some action going on, doesn't it? As you see it kind of turning yellow and brown, and we're starting then to see the bubbles forming. Now we're getting close to, we're pretty much just past the 1 minute mark now, so you can record details. Again, not a lot to see in regards to the salt. The sugar has got some action happening though, doesn't it? And then as you look, it's tough to see much occurring in the lead. From where I'm at, I can see a little bit more as I see some of them start to get a little shiny as they start to melt a little bit. Now you'll notice coming from the sugar, as we get close to the 2 minute mark here, you're going to see those vapors coming out of it, don't you? I'm actually going to try and burn a few of those off because they smell a lot. It doesn't smell bad right now. It's really kind of a caramely smell, but it gets a little strong. So we've been going for a couple minutes now, so you can record your observations. Once again, if we look, we don't have much of anything occurring in the salt test tube. In the lead test tube, we can try to zoom in a little bit more maybe. Might see a little bit, some of it melting at the bottom there. The sugar, of course, is where the most of the action is happening. As we get ready for minute number 3. Burn a few of those, more of those fumes off. We've been going now for 3 minutes. Okay, so we can make our observations. Just 1 more minute left. 1 more minute. Again, take an inventory of what we see happening. Salt pretty much is as it began. Sugar, we got a nice little bubbling black cauldron in there. Now I got the flame coming, burning right off from the top of it. And that actually, while it looks kind of scary, does help with, as I mentioned, the odor in the room, if you will. Just about 5 more seconds of cooking and we'll reach our 4 minutes. All right. So now if you want to make your last observations, what you see happening and I know for the sugar, of course, now is starting to look like it's about ready to overflow. I'm going to turn off that burner. The salt, we saw nothing happen. The lead is the hard one probably for you to see inside there. So what I'm going to do is I'm actually going to take it off. I'm going to take this off, and we'll get to see in there some of the melted material. You see it pour out of there. It is quite warm, this test tube. Got any more to pour out? I got most of it out. All right, but you get a pretty good view then of the lead that was melted and came out. So hopefully we can fill in our data tables from what we see there. Those observations. Again, for the salt, not much happened at all. The sugar, we got that. Now it's all kind of this black, crusty material that's left over. Okay, and then we saw the lead melted into that shiny silver material. Metal. All right, questions that you have about that? Well, let's look back quickly at our analysis and conclusion questions then. Hopefully the data table's all set. first question is just asking, well, what type of bond is holding each of these three different substances together? What's the bond in the salt? What's the bond in the sugars? And what's the bond in holding lead together? And it probably doesn't take a rocket scientist to know that we showed three different bonds. We showed an ionic, we showed a covalent, and we showed a metallic bond there. But question number 2 really gets to the heart of it, because we want you to be able to know what type of bond is at work in different situations. If you just look at the chemical formula or symbol, hopefully you can maybe make that identification. Okay. And what we're really wondering at is, well, what types of substances are being glued together, if you want to think of it that way, that are held together? Do we have a metal and a non-metal? Okay, in which case you've got your ionic compound, or do you have two non-metals? They're making a covalent bond then, or do you just have metals involved? Of course, then you're making a metallic bond. So that's kind of what question number 2 is pointing us towards. Question number 3 then asks, butter, not that we had butter here, but we're all familiar with it, is a common material that's easy to melt. Do you think it's most likely ionic, covalent, or metallic? And then explain your answer and maybe tie it into what we saw today. Now, real quickly, most of you know a little bit about butter, I'm sure, but butter really is a fat and protein from milk or from cream. I don't know if you've ever seen butter churned before, but it's one of those biological compounds. And so, again, we're talking about some of those organic molecules and what kind of bonds hold those together. And then last but not least, question number 4 asks, what causes a material to have either a high or a low melting and boiling point? And how does that apply to what we saw? Well, again, that's going to go back to something that we discussed earlier today called intermolecular forces. It doesn't tell you whether you've got a strong or a weak bond, for instance. Think about, our example today, nitrogen gas, okay, N2, really strong bond, strong triple covalent bond. And yet it boils at an extremely low temperature because it has very little intermolecular forces. In other words, the forces holding molecules together with their neighboring molecules. So, maybe you've heard of, liquid nitrogen. It boils at negative 170 degrees Celsius or something crazy like that. Okay, but that has to do with intermolecular forces. And so I want you to try to find out what those are a little bit more and use that to answer your questions. All right. Well, questions that you have. Hopefully that sets the table nicely for us to finish up our lab report.